Okay, so we should be live. Just gonna wait for a few more people to show up. Okay, so we're just gonna give it another couple of minutes, and then we are going to start the stream. It's a pre-recorded stream regarding logging, testing, and other things on Linera. So building on what we did last time. Just building on what we did last time with our fungible application. Okay. If there are any questions, again, feel free to ask in the chat. And excuse me, and I'll be more than happy to answer as we go along. I'll be looking at the chat. So yeah, let's just give it one or two more minutes, and then we'll start the stream. Okay, cool. So yeah, gonna start the stream now, and it's about like 30-40 minutes, I think. And yeah, again, if there's any questions on the chat, I'll be around to answer anything. Hello and welcome to the second Linera coding workshop. My name is Christos. I'm a software engineer at Linera, and today we're going to be building on the fungible application we built in the previous workshop. And specifically, we're going to be doing 4 things. So the first is we're going to be adding initialization arguments to our application so that we can seed our fungible application with an initial value, an initial amount of tokens that belongs to the creator of the application. The second thing is we're going to add logging to our application so we can actually see what's happening in the application. Third, we're going to be adding unit tests. And then finally, we're going to be adding integration tests, and we'll get into that in a little bit. So yeah, let's get started. The first thing we're going to want to do is we are going to create a local network. So we're going to use the Linera net app command. And that's going to spawn, as per usual, a validator with 4 shards. And also it's going to ask us to export the wallet and storage, which we're going to do in a new terminal. And if we just run Linera sync balance, this is like a sanity check, synchronize the balance of the validator. And if you get an okay here, basically you're good to go. So in order to add a initialization argument to our application, basically we want to seed our contract with a certain amount in the initialize method. And the initialize method takes an argument here called _argument. We're going to rename it to argument because we're going to use it. And it's of type self-initialization argument. And if we go to self-initialization argument, it's defined in librs, which contains the ABI. And right now it's the empty tuple. But we're going to change this to our amount type. And what we're going to do here is, we're going to rename this to amount as well. And we're just going to replace the amount from string here, which we were kind of hard coding and manually parsing. We're going to just replace that with amount. And then we're going to cargo build. And we no longer use from string, which is fair enough. So I'm just going to delete that, cargo build again. And yeah, it looks like we're compiling. So now to test it out, what we're going to do is we're going to use the project publish and create command. So Linera project publish, so publish the bytecode and create the application. And we're going to pass a JSON argument. And the JSON argument is a string type. And the reason it's a string type is because the amount type is 128 bits. And so if I go to the definition of the amount type, it's 128 bits. And JSON doesn't actually have native support for 128 bits. So in the background, we have our own parsing around amounts and our own internal logic. So we're going to specify some value, let's say 50,000 here. And then we're going to run this. And we have published our bytecode and our application successfully. Okay, so next we're going to just check the state of our application to make sure that it has indeed been initialized with the correct value. So we're just going to run the Linera service. And we're going to head over to localhost 8080, where we're going to see the GraphQL IDE. And let's first just query all of the applications that we have. So applications link. Yeah, this is for a given chain ID, where the chain ID is the default chain, which we should be able to get by running Linera wallet show. So we'll get the default chain ID, service, and this is the link to our published application. So we're just going to head over there. We can check out the schema of our application here. So we can get a list of all the accounts by just querying the account keys and giving a limit of, let's say, account. We only have one account, so we can just do one, and we get back this account key. And then we can just query the accounts to see the balances. And we see an amount of 50,000, which corresponds to the initialization argument we specified. What we're going to do now is we're going to commit our changes. We're going to add the commit, added initialize, oops, how do you spell that? Argument, contract. Okay, and that's initialization arguments done. Okay, so next what we're going to do is we're going to add logging to our application. So to do that, we want to add the logging dependency. So I'm going to clear this quickly, and we're going to do cargo add log. And this is going to add the log crate, which works out of the box with Linera. And what we're going to do is we're going to go into contract, and we're just going to log some key, some like critical parts of our application. So for example, when accounts are initialized, we can log info accounts initialized for owner with amount. I don't actually remember if these guys are debug or not, or if they're display. So I'm just going to do this cargo build. See if that works. Yeah, okay, that works. And then maybe we'll highlight the key parts of our application. So when we're crediting someone, account credited by. Okay, and we'll do the same for debit. So here, account debited by this amount. So now cargo build again, just to make sure everything compiles. And now what I'm going to do is I am going to actually kill the old network, run it again, get my new wallet and storage, copy paste those here, and then I'm just going to publish and create my application again with the initialization value of 50,000. And hopefully we should see in the network here, we should see the logs. Accounts initialized for owner X with amount 50,000. And that's how logging works in Linera. Now, we've been writing these applications, but how do we know that they work? How do we know that what we're writing is indeed correct? And in software engineering, when we want to make sure that what we're writing is correct, we use tests. So let's write some tests for our application. Linera application tests come in two flavors. The first are unit tests, where they're pretty much like Rust unit tests, where you essentially test the types that you're working with. And the second is integration tests, where we run essentially a mock validator and execute the application and simulate chains. So we're going to start with unit tests, and then we're going to get to integration tests. What I like to check initially is if my initialization logic is correct. So if from an initialization argument, we get to the correct final balance. So that's what my unit tests is going to check. So we're going to just specify that this block of code is only compiled in test mode. And in fact, we're also going to specify the architecture that we want to compile for, target arch equals wasm32. And this is important for reasons we'll get to when we do the integration tests. So then we'll name our module pubmod tests, and we'll specify, we're going to use super, whoops, not super, super, and we're going to use WebAssembly test, which is what we use to specify, to annotate our tests. And let's just start with a test we know is going to fail. So WebAssembly test, pub fun init, we're testing initialization, and I'm just going to do assert false here. So this test should fail. Let's build first of all. Okay, and then to test a project in Linera, you can use the Linera binary and do a Linera project test. And this is going to run unit tests and integration tests, and our tests failed, which is expected. Here you can see the WASM backtrace for where it failed, which is useful if you're trying to understand exactly what happened. And we're getting a helpful little link here, which tells you, yep, you failed on line 68, which makes sense. So if we replace false to true, and we run the tests again, Linera project test, all of our tests pass. Okay, so let's write a test to check our initialization functionality. Now, to do this, what we're going to do is we are going to create a mock version of our fungible token, our fungible token state. So I'm just going to define a method called function create and init, and this is going to return a fungible token type. And our fungible token type has these, well, it's a view, right? And we talked about views in the last workshop. But views have a context, and in this case, it's the view storage context. So we want to mock that context for our test, because we're not actually going to be using an underlying database or anything like that. And to do that, what we're going to do is we're going to use the Linera SDK test module, so Linera SDK test. And what we're going to do is we are going to use the mock key value store method, which is just going to initialize a mock key value store for us so we can use it as a context for our views. So then we're going to do let store equals view storage context default. You need line 73 in order to call line 74, and line 74 doesn't panic essentially. And then we're going to initialize our fungible token state with that store. So let's need fungible, fungible token equals fungible token load, which loads the view from a context. And in this case, we're going to give it the store. And we're going to call now or never because we don't want to await. And then we're going to unwrap. Let me import that quickly. So this is now or never from futures ext. And actually, let me make maybe the font a bit bigger here. Yeah, maybe that's better. Okay. Okay, perfect. Now that we've loaded our fungible token type here, what we're going to do is we're going to initialize the fungible. So we're going to call the initialize method on the contract. And to do that, we're just going to write let result equals fungible token dot initialize. Initialize takes two arguments, an operation context and an amount. So for our operation context, we are going to give it a dummy context, I think, dummy context. And this is a method we haven't defined yet. We'll define it in a bit. And for an amount, we'll do amount from str 50,000 or something. Dot unwrap. Use the import method here. And then again, we'll call it now or never, and we're going to unwrap. Perfect. So let's just perform a sanity check and check that the result is okay. And let's also return our fungible type. Our fungible token variable from this method. Okay, perfect. So let's define the dummy operation context quickly. So function dummy context, which is just a kind of mock context we'll be using for our unit tests. Let's see, which import do we want? Yeah, this is the one. And we're just going to return an operation context and give it some dummy variables. So chain ID, which is all zeros, 04 dot into. Okay, so in terms of our authenticated signer, we'll leave this unimplemented for now, and we'll come back to it in a bit. In terms of the height of the context, we're just going to give it a block height of 0, and the index is going to be 0. Perfect. Let's also define a method which generates a mock owner, which is going to be the creator of our application. So I have a public key here that I know parses, and I'm just going to define this creator method, which returns this owner. And we're going to remove this unimplemented block and replace it with creator. And we're almost done. The last thing we want to do is we want to actually test, actually write the assertions that test the creation of the fungible token application. And we're going to do let fungible equals create an init, and we'll give it an initial amount of, this shouldn't be here. This should be amount. Yeah, so we'll define that here, amount. We'll pass amount here. And this is where we'll give it the 50,000. And then we'll do assert equals fungible dot balance for a given owner. Again, the owner here is the creator of the application. And we're going to call the future immediately and unwrap and assert that that is equal to initial amount. And just so I'm not repeating myself, I'm going to define that here and replace this initial amount and initial amount. Okay, perfect. What do you not like here? Creator. This should be optional, so I'm going to put some. And now if we do cargo Linera project test, we get a compilation error, initialize is not found, which is fair enough because because I'm in the wrong file. So this is state RS, this test should be in contract because it's testing the functionality of the contract. Okay, so let's go back to contract and put this in here and Linera project test. And we're missing one import, the view storage context import, fair enough. So let's just import that quickly. And our tests pass. So that's our unit test done. We've tested that the initialization logic of our application is correct. Cool, now that we've finished our unit tests, let's just clean everything up and commit our changes. So first of all, I'm gonna format my codebase to make it a little bit prettier. Then I am going to check for unused imports. So Linera project test. Yeah, the test module isn't necessary here, supposedly. I guess because we're qualifying it here explicitly. Really? Does this work? Right, okay. So, yeah, I mean, that's fine. Perfect. And now we're going to get status, git add, git commit, added unit tests. Great, now let's move on to integration tests. So moving on to integration tests, one thing that I didn't mention when it comes to unit tests is that unit tests run on the WASM32 architecture, whereas integration tests don't, because integration tests actually start a mock validator and deploy your code there. So we're going to need to add a couple of more dependencies for our integration tests. These dependencies are used for unit tests, and what we want to do now is we want to add dependencies when dev dependencies when the target architecture is not WASM32. And we're going to, again, have the Linera SDK with the test feature flag. and also the Wasmer feature flag. And we're also going to use a Tokio runtime with macros and the multi-threaded feature flag. RT multi-thread, I guess, multi-threaded runtime. Integration tests in our application are going to live side by side with the source repository. So we're going to create a new directory. Actually, I'll do it here to make it a little bit easier. Make your tests, cd tests, and we're going to create a file called cross-chain tests.rs. And we're just going to open cross-chain tests here and leave me alone. We're going to reload the project in my IDE. And the first thing we want to do is we want to tell the compiler that this is only going to run when the architecture is not WASM 32, so the native architecture instead, WASM 32. And this should be config with a G. Okay, perfect. So quickly, we're just going to do Tokio test, because we're going to be using that multi-threaded runtime, and we're going to define async function test cross-chain transfer. Okay, so let's take a step back here. What do we really want to test? The fungible token that application that we wrote, the main functionality is user A on, let's say, chain A sends money across to a different chain, let's say chain B to user B. So what we really want to test is that user A on chain A starts with a balance of X, and then sends a certain amount of tokens to user B on chain B, and then they end up with Y, where hopefully user A sent Y tokens, and then user A is left with a balance of X minus Y on their chain, right? That's the crux of our application, and that's what we want to test in our integration test. So we'll call X and Y initial amount and transfer amount to make our life a little bit easier. So let the initial amount equals amount from, and then we'll start them off with, on chain A, we'll start them off with 1,000,000, U128, and then let transfer amount equals amount from, let's say, 50,000 that we're transferring to chain B. And let's quickly run this test. This will obviously fail because it's we're hitting an unimplemented. Okay, perfect. It compiles and it panics, which is correct. Next, what we want to do is we want to create a test validator that we can deploy our application to, create our chain A, deploy our application on chain A, and then create chain B where we can send money to. So let's create our validator. And to do that, we're going to do let validator bytecode equals test validator with current bytecode dot await. Oops, I should be here. Dot await. And what this method does is it creates a test validator with the deployed bytecode, and this is the bytecode ID we're getting back. This should in fact be bytecode ID, which corresponds to the current crate which we're in, so the fungible crate in this case. Next, let's create the sender chain. So this is a chain A in our example, equals validator dot new chain dot await. Next, let's create the account of the sender. Sender account equals owner from sender chain dot public key. Okay, perfect. So we have the sender chain, we have the sender account. Now let's deploy our application. So we're going to get back an application ID from the deployment process, sender chain dot create application. And since we know the application at compile time, we can use the ABI and get the type system to help us out here. So we're going to specify the bytecode ID that was the result of the test validator with current bytecode. Our initialization, our parameters are empty, so I'm just going to keep that as the empty tuple. the initial amount we want is initial amount, and then our dependencies are empty. This application does not depend on any other application. And finally, since this is an asynchronous operation, we're going to await. Great. Now let's build the receiver chain, or chain B in our example. So let receiver chain equals validator.newChain. Our mark validator is just going to create a chain for us, and we're going to call the receiver account the public key of that chain. So account equals owner from receiver chain dot public key. Great. Okay, so now that we've set up the sender and receiver chain with the initial amounts, the next thing we're going to do is we are going to, on the sender chain, create an operation. So we're going to create a block with the operation inside, and that operation is going to specify that we want to transfer a certain amount from the sender account to the receiver account. So let's try that out. Sender chain, and this is sender chain is of type active chain, so something like this. An active chain is a type that describes a chain inside a test validator. It's kind of a convenience method. And what we're going to do is we're going to say sender chain dot add block. For some reason, my ID is not picking up this test code, so we're going to not rely on autocomplete that much. And what we're going to do is we're going to pass a closure which defines a block with an operation, and this operation is going to be for a specific application ID, and we're going to define our operation to be operation transfer. Again, this is typed because we are using the ABI of the fungible token here. The types here are node at compile time. Obviously, like blocks in production systems are kind of opaque bytes because the type system doesn't really know which application the operation corresponds to. So, okay, the transfer operation, if we recall, let's go back to our librs here, has an owner, an amount, and a target account. So let's write those out. So our owner is the sender account. Our amount is what we defined up here, the 50,000, the transfer amount. And our target account is an account type where the chain ID is the active chain receiver chain dot ID, which gives us back the chain ID for that active chain, and the owner is just the receiver account, which we defined here. Perfect. And this is an asynchronous operation, so we're going to await it. Okay. So what we've done is we've created chain A, deployed our application, created chain B, and now this operation that we just added, this block that we just added with an operation is going to transfer money from chain A to chain B. So now we want to do two assertions. The first is that our user A on chain A has been debited by the transfer amount, and the second is that our user B on chain B has been credited by that same amount. Okay, so let's first check on chain A. Assert query account. This is a method that doesn't exist yet. We're going to write it in a little bit. So we're going to query a given application ID on the sender chain for the sender account. And we're going to await because it's going to be an asynchronous method. And we're just going to check that the balance of the sender account on the sender chain is initial amount minus, so saturating subtract the transfer amount. Simple as that. Okay, now let's define our, I'm going to remove the unimplemented, it's no longer necessary, I don't think. And I'm just going to quickly define the query account method. So pub async fun, actually doesn't need to be public, just async fun query account. And we're going to query for a given application ID, which is generic over the fungible ABI, for a given chain, which is again an active chain, and an account owner, which is an owner. We're going to return an option of amount. Again, option because we could ask a question about an owner. We could submit a query about an owner which is not registered in a given chain. So to perform this query, we're actually going to go via GraphQL as our service here. Source service exposes a GraphQL interface. So we're just going to hard code the GraphQL in our test. Let's go back to cross-chain tests here. So let query equals format. We're going to do some string formatting here. Query, we need to escape the parentheses. And we're just going to query accounts, owner, just put the owner in here and escape the parentheses again. And finally, we're going to do account owner dot to value. Perfect. Next, we're going to actually perform the query. So chain.graphql query application ID query.await. And we're going to dynamically traverse this value in order to get the actual balance out. So let balance equals value as object, I believe. What do you want? This should be, yeah, it should be like this. Dot get accounts dot as string. Yeah, because we wanna get the balance into a string and then finally parse it into an amount. Balance dot parse dot unwrap. Okay, perfect. We're missing a semicolon here. And now if I Linera project test, we're probably missing an import of some sort. Yeah, okay, so we're missing a few. Let's see, test validator, owner, and active chain. Cool. So let's do use Linera SDK test. What was it? Active chain. I'm not sure, where is active chain? Yeah, it's just here, okay. Active chain, owner, and then test validator. And there's no owner in test. Oh, so we need, right, yeah, this is base owner. Owner here. Test. Okay, and the last thing is application ID is not generic. That's fair enough. We're probably using the wrong application ID, the non-generic one. The application ID we want in this case is in Linera SDK base. Yep. So, yeah, okay, this is not the one right. SDK base, minop should be here. Okay. Now, let's see here, I've probably mismatched a parenthesis or something. Oh, right, okay. Yeah, so what I was missing is a semicolon at the end of block with operation. And the final thing is there is no method to value found on owner because this is a trait exposing it. So we're just going to use async GraphQL base, is it input type or scalar type that we want? I'm not sure. Yeah, it's just input type. So async GraphQL input type. And Linera project test. Perfect, and our test passes. Now we haven't done the final part, which is to test the receiver chain to make sure that that amount was received and the correct account was credited. Okay, so so what's happened here is on the sender chain, we've created a block. That block has the operation transfer, and that operation debited a certain amount from user A on the sender chain, and we've sent a cross-chain message to chain B. Now, chain B doesn't have to handle that message. In fact, we need to kind of prod chain B to handle the received messages. And for this reason, we're going to use the handle received messages function. So receiver chain dot handle received messages. And what this is going to do is it's going to receive all of the queued messages in all inboxes for that chain, and it's going to add a block to the chain that receives all the queued messages in the inbox. So let's, so now that we've received the messages, created a new block, now the balance should be correct. And what we're going to do is we're going to assert equal. Again, we're going to use the query account method we defined earlier. Query account, application ID, on the receiver chain, the receiver account. And we're going to wait, again, because it's asynchronous. And the amount that's been received by user B on chain B should be the transfer amount. Yeah. So let's just run that test. Perfect. It all seems to work. Okay, so that was today's workshop. It was a little bit lighter than last time. And what we've done is we specified custom initialization arguments for our application. We added logging to our application so that we can understand what is happening. We tested the behavior of our application using initially unit tests. And then finally, we test the cross-chain behavior of our applications with integration tests. Thank you very much for watching. See you next time.